So part 3 of our notes on limits analytically here, we ended up with talking about limits of composite functions. So I want to give you another example of what that might look like and kind of show you where that's headed. So again, if we take a look at the limit of a function here, 2x squared minus 10. So that's our function g of x as x approaches 3. So again, because it's a polynomial function, we can do a direct substitution into that value of x. When we do that, we should come out with the value of 8. So this is our limit L. So when we start to take a look at the limit of our function f of x, which I've made the cube root of x, we're going to approach, x is going to approach this limit L. And so again, radical function, odd root, doesn't matter what value my x is approaching, I can go ahead and do a direct substitution and get 2. All right? So here, essentially, let's think about it. We took f of x, we did a direct substitution. So this value 2 is literally the function f evaluated at the limit of g of x, or in this case, capital L. All right? This should be the answer to the limit of our composite function as we approach this first value 3. Okay? So if I take f of g of x, so my cube root, I'm going to substitute 2x squared minus 10 into that cube root. And so we're taking the limit of the cube root of 2x squared minus 10. We want to approach, have x approach the value 3. So again, when I take and substitute that in, well, I know that 2 times 3 squared minus 10 is going to give me 8, because that's what we have right here. I know when I take the cube root of that, I'm going to get 2, because that's what I have right here. And that is f of L. So that's where that information is coming from. That's how that composite function is going to work in terms of the limit. Okay? Any questions? You're watching this on video. My bad. So, a couple other things will start to happen here. Let me give you a couple of quick examples real quick. Build this in here. I told you I would. So just direct substitution. So for example, the limit as x approaches 2 of 4x squared plus 3. So I can go ahead, polynomial function, direct substitution, 4 times 2 squared plus 3. That's going to give us 19. That's my limit. If we were to graph that on our calculator, and look what happens as x is approaching 2, we would see that our y value for that graph is going to approach 19 from the left and from the right. So that's the nice thing about direct substitution. You can get things a little bit quicker. If I have the limit as x approaches 4 of the square root of 2x. So that would give me 2 times 4 inside of that, which eventually gives me the square root of 8 over 2 radical 2. That's my limit. So we can do direct substitution, polynomial functions, radicals, we can do with rational functions as well. However, there are some instances where doing that direct substitution gets us into a little bit of a jam, if you will. All right, and that's what this next little portion is going to be about. So, if we have a rational function x cubed minus 1 divided by x minus 1, and we look at the limit of that function as x approaches 1. So we do our direct substitution, we get 0 on top, we get 0 on the bottom. You can't divide 0 by 0. We call that an indeterminate form. All right. So in terms of what we want to do with our limits here, I always tell kids that's a big sign. Okay, anytime we get that 0 over 0, that's a sign. All right. I'll sing a song about it when you get back in class one day. So what can we start to do then to help figure out where this limit is? Because again, we can sit there and plug that into a graphing calculator and look at it graphically, and I bet we find what the actual limit is going to be. But how can we do it algebraically? Well, let's think about x cubed minus 1. This is a difference of 2 cubes. So we can start to factor that, and we factor that into x minus 1 times x squared plus x plus 1. Our denominator becomes x minus 1. And I'll explain more about how this is going to unfold in part 4 of our video sequence.